So good morning friends. Last time we had discussed about the property of charge called as quantization of charge. Today we'll discuss the next property of charge, which is called as charge is invariant. So I'll put this next property, the fifth property, charge is invariant. So as the word would imply to you that it doesn't change. Invariant means something which is constant, it doesn't change. So what is the meaning of this? To understand this concept of charge being invariant, we have to understand the concept of what was derived by Albert Einstein in special theory of relativity. That is, as per special theory of relativity, length, mass and time are frame dependent. I hope you are conversant with what is meant by frame. That is called as frame of reference in physics, which we classify either as inertial or non-inertial frames. So what did Einstein precisely mean about length, mass and time being variant or varying with the frame of reference? He told, as per his theory of STR, that if I have two frames of reference, say S1 and S2, S2 moving with a velocity v with respect to S1, this frame is nothing but rigid coordinate systems XYZ. We'll assume that there is a observer in frame S2 who is looking at a mass and measures the value to be m0. There is another observer in frame S1 who is also observing this mass m0. The reported value of the masses measured by the two observers would be like this. For the observer in frame S2, the mass will be m0. For observer in S1, the value of mass will be m0 upon root 1 minus v square by c square. So you're able to see that there is a transformation equation between the frames for the property called mass. Similarly, length and time also gets transformed into different formulas. So length, mass and time, they don't remain the same in the other reference frame. But as far as charge is concerned, if this mass has got a charge of q, the same person would be reporting that S2, the person in the frame S2 would report the value of charge to be q, and S1 also will report the charge to be q, which clearly shows that charge does not vary from frame to frame. So it's frame independent entity. Now this is the fifth property. We'll come to the sixth property. Let me remove this now. The sixth property says that every charge has mass. That means that any body which has no mass cannot carry charge. I can give an example in this case. For example, if you talk about a photon, we all know about photon. Photon is the quantum of light which you studied in our 11th standard chemistry. That is the atomic structure. Photon is the quantum of light, the unit of light, and we know that the rest mass of photon is 0. The rest mass of photon being 0, it does not have any charge. We can also take another example of a neutrino, which has negligible mass and 0 charge. So these two observations in nature substantiates the fact that every charge is supposed to have mass. Without mass, there cannot be any charge. two points which we had missed discussing earlier under the topic of charge is, one is called as pair production. Take it as a extra topic. Pair production. Now, what is this pair production? I think you are familiar with the electromagnetic spectrum. That is, if you arrange the various electromagnetic waves in the order of their wavelengths, for example, this is frequency increasing, this is a radio waves, this is micro, this is infrared, ultraviolet, visible, X-rays and gamma rays. So you are able to see that in the frequency spectrum, gamma rays is at the highest, so therefore gamma rays carry a very large amount of energy. So what is pair production? If a gamma photon is moving near a heavy nucleus, if a gamma photon is moving near a heavy nucleus, then it is found to sometimes get converted to an electron and a positron. So it's getting converted to a pair of particles, positron being the antiparticle of electron. So therefore a gamma photon which is neutral does not carry any charge. If it has sufficient energy and passes near a heavy nucleus, it gets converted to an electron and a positron. So we can write down this elementary particle reaction as gamma 00 becoming an E minus 10 plus E plus 10. Of course, energy and momentum are conserved here, including the angular momentum. So you're able to see that once again nature is demonstrating that no reaction is possible in the universe without conservation of charge. So here you are able to see on the left hand side that a gamma, which is neutral photon, is getting converted to an electron and a positron. Now the second small topic which was missed out in the charge topic was which is called as fractional electronic charges. I'll take up that. Now, if you're familiar with the atomic model, you know that an atom consists of, I'll put the topic as quarks. An atom basically consists of a nucleus and electrons revolving around it. And the nucleus is composed of neutrons and protons. Now, if the neutrons and protons are further looked in, the theoretical framework of particle physics says that a neutron is basically composed of quarks. Now these quarks, out of which they are made up of, are called as up quark and down quark. An up quark carries a charge of plus 2 by 3 times the charge of an electron, and a down quark has a charge of minus 1 by 3 times the charge of an electron. So if I want to combine these two charges, the minimum numbers to obtain a neutral particle, then we would require 2 down quarks and 1 up quark, because once you add 2 down quark with 1 up quark, you will get a 0 net charge. So therefore a neutron consists of 2 times a down quark and once an up quark, which is 2 times minus 1 by 3e plus 1 times 2 by 3e, which is equal to 0 charge. So this is what is in the theoretical framework of particle physics. But you must be asking, how did you take the quantization of charge as 1e, whereas there are some particles with charge of 2 by 3e, which is less than the charge of electron, or minus 1 by 3e, which is again less than the charge of an electron. The reason why it is taken, the electron's charge is taken as the smallest one, is because quarks have never been isolated separately. That's because of their extremely large binding energy. And the day the quark is isolated separately and shown in the laboratory as an independent entity, then we would not take the quantization of charge as 1e. Similarly, for making a proton, we will require 2 up quarks and 1 down quark. Let us see the logic behind it. If you take 2 up quarks, then 2 times 2 by 3e will add with 1 times minus 1 by 3e, which will be 4 by 3 minus 1 by 3e, which is 1e. So you are able to see that if I combine 2 up quarks with 1 down quark, you are going to get a particle with a charge of plus 1e, which is definitely the charge of the proton that we have inside the nucleus. Now once we are through with this, we have been able to complete the topic on charge.